Machine ethics, or machine morality, is the part of the ethics of artificial intelligence concerned with the moral behavior of artificial moral agents, AMAs, e.g. robots, and other artificially intelligent beings. It contrasts with roboethics, which is concerned with the moral behavior of humans as they design, construct, use, and treat such beings. Machine ethics, sometimes referred to as computational ethics, and computational morality. History. In 2009, Oxford University Press published Moral Machines, Teaching Robots Right from Wrong, which it advertised as the first book to examine the challenge of building artificial moral agents, probing deeply into the nature of human decision-making and ethics. It cited some 450 sources, about 100 of which addressed major questions of machine ethics. Few were written before the 21st century. In 2011, Cambridge University Press published a collection of essays about machine ethics edited by Michael and Susan Lee Anderson, who also edited a special issue of IEEE Intelligent Systems on the topic in 2006. Articles about machine ethics appear on a regular basis in the journal Ethics and Information Technology. Major questions. Is this study urgent, or even non-fiction? In 2009, academics and technical experts attended a conference to discuss the potential impact of robots and computers, and the impact of the hypothetical possibility that they could become self-sufficient and able to make their own decisions. They discussed the possibility and the extent to which computers and robots might be able to acquire any level of autonomy, and to what degree they could use such abilities to possibly pose any threat or hazard. They noted that some machines have acquired various forms of semi-autonomy, including being able to find power sources on their own, and being able to independently choose targets to attack with weapons. They also noted that some computer viruses can evade elimination, and have achieved cockroach intelligence. They noted that self-awareness, as depicted in science fiction, is probably unlikely, but that there were other potential hazards and pitfalls. Some experts and academics have questioned the use of robots for military combat, especially when such robots are given some degree of autonomous functions. The U.S. Navy has funded a report which indicates that as military robots become more complex, there should be greater attention to implications of their ability to make autonomous decisions. The president of the Association for the Advancement of Artificial Intelligence has commissioned a study to look at this issue. They point to programs like the language acquisition device, which can emulate human interaction. Which specific learning algorithms should be used? Nick Bostrom and Eliezer Yudkowsky have argued for decision trees, such as ID3, over neural networks, and genetic algorithms on the grounds that decision trees obey modern social norms of transparency and predictability, e.g. stare decisis. While Chris Santos Lang argued in the opposite direction on the grounds that the norms of any age must be allowed to change and that natural failure to fully satisfy these particular norms has been essential in making humans less vulnerable than machines to criminal hackers. He has advocated for evaluative diversity among machines to match the diversity found in effective human teams. How should AMAs be trained, e.g. instructed/rewarded/punished? In 2009, during an experiment at the Laboratory of Intelligent Systems in the École Polytechnique Fédérale of Lausanne in Switzerland, robots that were programmed to cooperate with each other in searching out a beneficial resource and avoiding a poisonous one eventually learned to lie to each other in an attempt to hoard the beneficial resource. One problem in this case may have been that the goals were terminal, i.e. in contrast, ultimate human motives typically have a quality of requiring never-ending learning. What implications, if any, do answers to the above have for human ethics? In Moral Machines, Teaching Robots Right from Wrong, Wendell Wallach and Colin Allen conclude that attempts to teach robots right from wrong will likely advance understanding of human ethics by motivating humans to address gaps in modern normative theory and by providing a platform for experimental investigation. Approaches. Several attempts have been made to make ethics computable, or at least formal. Whereas Isaac Asimov's 3 laws of robotics are usually not considered to be suitable for an artificial moral agent, it has been studied whether Kant's categorical imperative can be used. However, it has been pointed out that human value is in some aspects very complex. The way to explicitly surmount this difficulty is to receive human values directly from them through some mechanism, for example by learning them. Machine ethics in fiction. Isaac Asimov considered the issue in the 1950s in his I, Robot. At the insistence of his editor John W. Campbell Jr., he proposed the 3 laws of robotics to govern artificially intelligent systems. Much of his work was then spent testing the boundaries of his 3 laws to see where they would break down, or where they would create paradoxical or unanticipated behavior. His work suggests that no set of fixed laws can sufficiently anticipate all possible circumstances.